Hey, it's Ms. Reese, and I'm going to go over the Desmos problems from page 13 through 15. So the first thing, we'll kind of set up the problems, put the numbers on the diagram, and then we can see what type of ratio we're using. So here in our first problem, we have a 78-degree angle. Let's add that in here. 78 degrees is our angle that's created by the ladder and the ground. So here's the ladder side, this is the ground. So that would be where our angle is. It's the angle of elevation, okay? And we also know that the base of the ladder is 5 feet from the building. So I'm gonna put a 5 here. And you can almost imagine this is the ladder kind of leaning against the side of the building, okay? And what we are looking for is the length of the ladder. So I put an X here for the hypotenuse. So then we identify, so now that we have it set up, it's really just a sine, cosine, tangent problem. From 78 degrees, this side is next to it, adjacent. This side is a hypotenuse. So I say, okay, sine, cosine, or tangent, SOHCA or TOA. Well, I have an adjacent and hypotenuse, and I'm going to use a regular sine, cosine, tangent for a missing side, because that length there, the ladder, is a missing side. So my equation that I would type here is the cosine of 78 degrees is equal to 5 adjacent over x hypotenuse. Now remember, if I was trying to isolate this, my cross product would be x times cosine 78 equals 5. I would then have to divide by cosine 78 on both sides. Remember, anytime your variable's in the denominator, we think to ourselves divide. So it's 5 divided by cosine 78. And I would just copy and paste this entire answer from here into your answer box. And if you want to write down on your packet, you can write the rounded answer to 3 decimal places. Okay. On the second question here, we are looking for the angle of elevation. So find the angle of elevation. That would be here. I'm going to call that theta. And then we're given that a telephone pole is 12.5 and that the length of the shadow that it casts on the ground would be 18. So if you imagine a shadow where you would see it, that would be on the ground. So I'm going to put an 18 here. So then we say, okay, from this angle we're solving for, we have this side here across, it is an opposite leg. This side here, which is next to it, that is an adjacent leg. So then I would say O and A, that's a tangent ratio. That's a TOA. And because this is an angle that I'm solving for, I use an inverse tangent ratio. So I can type that in here, inverse tan of, or I know I saw some of you just write tan -1. That's fine. To get the exponent, you could do a little caret symbol on the 6, like shift 6, tan -1, and then in parentheses, we would say 12.5 opposite over adjacent 18. Now the problem is this does not give us our solution in the proper degree format, so we really do have to copy this into the calculator. I'm just going to copy and paste it. Or you could click this function button to get the inverse ratios as well. So then we can just copy and paste that into our solution here. Here we have an angle of depression question. So we've got a 36-degree angle. So I'm going to put 36 here for the angle of depression. And we've got from the balloon to this person here, pretend there's a person here, we've got a 75-foot string. So I'm going to put 75 there for the hypotenuse. And we are looking for how high the balloon is. So I'm going to put from the ground, okay, that would be this length here, x. Now the problem is with this 36 outside the triangle, I can't really use it to help me solve. So I can just replace it and put it here as an alternate interior angle. That would be congruent to it. So now I'm going to kind of get rid of this angle. I'm not using that one anymore. So what I am using is from this 36-degree angle that's now inside the triangle, I have this side, which is an opposite leg. It's across from the 36-degree angle. And then I have this side, which is a hypotenuse. It's across from the right angle. So we have opposite and hypotenuse. That's a sine ratio, SOH. And I'm solving for a side, so it is a regular sine ratio. So I should be able to say sine of the angle measure, 36, is equal to opposite over hypotenuse. Now, when you put this into your calculator, we've got sine 30, so we've got 75 multiplied by sine 36. I want to show you something that you might want to be careful of as you're inputting things into a calculator. If you did sine 36 first, and then you multiplied it by 75, you're noticing, okay, this answer looks very interesting. It's off. So you need to make sure that if you do the sine first, that you're putting it in parentheses. So you want to take the sine of 36 first, and then it needs to be multiplied to 75. Or what I always do is I just do my number and then multiply it by the sine, cosine, or tangent for whatever. Okay. So we've got here 44.084 would be rounded to the nearest fourth, or thousandth, 3 decimal places. We'll try one more completely together, and then I'll be setting up the rest, but not doing them completely. So we've got one more together. We've got from the top of a 120-foot tower. So this is 120 feet, and we've got 400 feet here. We are looking for the angle of depression. Okay, that's the angle of depression. What we need to solve for first is going to be this angle here, which is congruent to. So from that angle, this side's opposite. This side is an adjacent leg. And so we're going to use an inverse tangent again, very similar to our second problem. So inverse tan, because it's an angle that we're solving for. Oops, that didn't copy out properly. Of 120 divided by 400. And again, that's not in the proper format calculator mode, and I can't change that one for some reason. So I'm just going to type that here, or you can type in this as well. This would be 16.699, 699. All right, so I'm going to get this one set up for you. So we've got Jada is 10 feet from the base of a tree and spots a nest sitting on a branch. So we've got an angle of elevation here of 55 degrees. And she is 10 feet from the base of the tree. And we are looking for, she spots something up here at the top of the tree. It's a nest that she's looking at. And we want to know how high off the ground that is. Okay. So we've got from that an opposite leg. We've got an adjacent leg. That's going to be a tangent ratio, and it's a regular tangent ratio. So tan of my angle is equal to opposite over adjacent. Okay, so you can type your equation here, and then you can go ahead and plug it into the calculator. This one's a little tricky. So we've got, imagine there's a building here. So my drawing skills are limited to stick figures and squares. So there's a building. Now from the top of this building to this hot air balloon, let's imagine this hot air balloon here. Okay, that's not good either. The angle of elevation is 76 degrees. So I'm going to put 76 degrees here. And we know the height of the building is 95. So that's going to come into the back end of the question. We also know the horizontal distance from the building to the balloon is 354. And we're looking for the height that the hot air balloon is off the ground. So I'm going to call that X. Now, what you're going to do is you're going to say, well, this side's opposite, this side's adjacent. That's a tangent ratio. So you're going to do tan of our angle equals opposite over adjacent. But what you need to do when you're finished with that is you need to say, okay, well, whatever I get for X, I need to add 95 to it. And then that will be the height of the building. Okay, so I guess I should say your answer here should not be X, it should actually be the height of the hot air balloon. Okay, so whatever you get for X in this triangle here, so X will represent this length. Whatever you get for X, just go ahead and add 95. Here we've got a fire hydrant in this question. Let's just pretend there's a fire hydrant. And it is 72 feet from a 125-foot building. And we are looking for the angle of elevation. So I'm going to put my theta here. So that means from that angle, we've got an opposite leg and we've got an adjacent leg. So that's going to be similar to how we set up question 2, opposite and adjacent, and we are looking for a missing angle. So just like this problem too. Question 8 here. Now this one could kind of be argued either way. I'll show you the way I set it up, and then I could see where it's set up a different way essentially, but we've got a 7-foot wave here. Imagine this surfer's at the top of the wave. The angle of depression is 10 degrees. I'm going to put 10 here, which, okay, we need to put that inside the triangle as well. And the distance from the surfer to the shore is what we're looking for. And so I calculated it as this. I was kind of thinking of the horizontal distance. That's what you're going to be able to check your answer with. But technically for this question, I think I could have argued that the distance could have been the hypotenuse as well. So really for either of those, it's kind of ambiguous. So I would have given credit for either solution or either answer. I think that's the only question where it's a little ambiguous. So from my 10-degree angle, we've got an opposite and we've got an adjacent. And remember your variable's in the denominator this time. So think to yourself, denominator. I'm going to have to divide my sine, cosine, or tangent ratio or whatever I am picking. Question 9, I will go over with you because this one's a little challenging. You see there's kind of 2 triangles here. So we've got our cell phone tower. This is the middle section, this piece here. We've got our 2 cables. So this length, this hypotenuse is a cable, and it's congruent to this other cable because we know that the distance from here is equivalent. So these parts here are equal, it's saying in the question. We also know that the angle of depression is 23 degrees, which I can then place inside my triangle, 23 degrees. And we know that the height of the tower is 140. So I'm going to put 140 here for the side length, this leg. Now what I'm looking for is I'm looking for the distance from here all the way over, from the cable to the cable. Okay, but what I can solve for first is this length here. I'm going to call it x. So we're going to solve for x. This is, we've got what, opposite from 23 degrees, we've got opposite, we've got adjacent. So you're going to solve for x, but know that when you solve for x, you are only solving for this length here. Essentially, that length can be doubled to get the length between the 2 cables. So you're just going to need to multiply your answer by 2 at the end of that. So this one's going to be tan 23 with opposite over adjacent equals opposite over adjacent. So remember, when you plug this into your calculator, you're going to be dividing. So 140 divided by tangent of 23, and then whatever that solution is, you are going to double it because we're actually looking for the distance between the cables. So I should have said, give the approximate value of the distance between the cables, not necessarily our variable x. Question 10, this was the start of the 2-page kind of review on, called it a scavenger hunt, but we have here from 23 degrees, this side is next to it, it's an adjacent leg. This side's also next to it, but it's not a leg, it's a hypotenuse. It's the longest side in that triangle. So we have an A and H, adjacent and hypotenuse. You're solving for a missing side. So you're going to decide, okay, is this a sine, cosine, or tangent ratio? And I'm going to use a regular sine, cosine, tangent because it's a missing side. Number 11, from 63 degrees, this is a leg and it's not next to it, so it's an opposite leg. This is a hypotenuse. Opposite and hypotenuse, what ratio do we use? And therefore, if we're using sine, cosine, tangent, it's a missing side. We're going to use a regular sine, cosine, or tangent. Here we've got a 37-degree angle. So I kind of drew this triangle upside down so we can see it as an angle of depression in this way. So we've got a 37-degree angle. Think of that as the angle of depression. And the balcony is 15 feet from the ground, so I'm going to put 15 here, 15 feet from the ground. How far is Romeo from the base of the house? So this would be our length here that we're looking for. So we have an opposite side, we have an adjacent side. So you can decide based on that, opposite and adjacent, you can decide which type of ratio we're going to use to set up that problem. Oops. Okay, question 13. The angle of elevation from Ben to the top of a telephone pole is 62 degrees. So I'm going to put my 62 here. Ben is standing 8 feet from the base of the pole, and the height is X. I'll label that as X. So I'm going to let you label these two sides as opposite legs or adjacent legs, and then use your sine, cosine, regular sine, cosine, tangent ratio. We've got a 24-foot wire tied from a stake in the ground to the top of a flagpole. That's going to be this length here. So imagine this would be like the flagpole. So from the stake in the ground to the top of the flagpole is 24. The angle of elevation is 53. How far is the stake from the base of the flagpole? So this will be your X. So then identify the X as an adjacent or opposite leg, and then 24 is a special type of side. So label that, and then you can use a regular sine, cosine, tangent ratio to solve. 15 here, we're solving for our missing angle. From that, this side's opposite, and this side is adjacent. So this is actually just like question 2, when we did an opposite and adjacent. So remember question 2, looking back on that. We did opposite and adjacent. We were solving for a missing angle. So I'll let you finish that one. And I think same with this question as well. This side, decide out of these two which is the opposite leg and which is the adjacent leg. And then you're going to use an inverse ratio for that.